Hi everyone. So I had a little bit of time between parent-teacher conferences, so I wanted to kind of shoot off a little video, nice and quick, about resonance structures, bond length, and something called pi and sigma bonds. So I've got this brand new stylus-y thing here, and let's just kind of talk about resonance structures. Okay, so let's say, for example, we have a compound. Let's say it's CO3, 2 minus. Okay, so if I were to draw that, it would look something like this, and this, of course, being an oxygen. All right, perfect. Now, you could just as easily draw it a different way. There we go. Still working on it, still practicing. Maybe my double bond could be over there. Okay, and my two single bonds over here. Or I could even draw it a third way, right? Where my double bond would be down in the middle. And I would have single bonded oxygens, okay? So I have these three different resonance structures, they're called. And they're molecules where the bond just is in different spots. It could be on this oxygen, could be on this oxygen, or it could be on this oxygen down here. This is all correct, all right? These are all the same thing. These are all 100% correct, right? Where that double bond goes is not necessarily, there's no rhyme or reason to it. It's just kind of random. So what we say then is that this double bond actually doesn't just stick with these two elements. In a Lewis structure, we think of electrons as belonging to one atom versus another, but that's not really the case. These form these clouds, they're called molecular orbitals, or these giant clouds around these molecules. So these compounds, the bond is actually shared between all three at the same time. So we could really think of it as each oxygen having a single bond, but that double bond being shared between the three. Okay, so that double bond is being shared between the three. So it looks something like this, where they would each almost have 1 1/3 bonds, not really a full. They would be stronger than a single bond, but weaker than a double bond. They'd be kind of in the middle, or in between. Okay, so it's important to realize a couple of key concepts here, and I actually did mean to go ahead. Okay, so let's talk about bond strength first. So in terms of strength, in terms of bond strength, oops, that's horrible. Let me erase that. Let me try it this way now. In terms of bond strength. All right, so my weakest is a single. That's my weakest. Okay, that means that it's the easiest to break, has the least amount of stability in it, takes the least amount of energy to break that bond. All right, a double bond, or two bonds, I'm not going to write double because already I'm pretty much like kind of testing the limits of this. It's kind of our middle. It has middle strength. You know, it's not really weak, it's not very strong, it's kind of middle of the road, or medium strength. And then finally, three bonds, or our triple bond, is the strongest. Okay, so this is, it would look like this on a Lewis structure, this one would have a double bond like this, and this would be a triple bond like that, okay? So it's really not one bond, two bond, three bonds, but single, double, and triple, but I'm already having trouble with my stylus, and it's just a steep learning curve and all that. So I have these three bonds. It turns out that the weaker the bond is, it also happens to be longer. Okay, so single bonds are the longest. These, once again, are kind of like they're shorter, but they're not the shortest, so I'll just say shorter. And then these are the shortest. Okay, so that means that the strongest bonds are also the shortest bonds, okay, and the longest bonds are the weaker bonds. So when we have resonance structures, like in the previous slide, which I will not try and go back to because I won't be able to, the single bonds are longer and weaker, and the double bonds are kind of a little bit shorter and a little bit stronger, but the resonance structure bonds kind of act in between. So they are longer, they're longer than a double bond, but not as long as a single bond, so they're kind of in between. And that's how we know that these electrons are being shared fairly freely within this molecule. So they're not really devoted to one atom or another, they're kind of shared across all of them pretty equally. Okay, so the last concept we need to talk about a little bit is the difference between a pi bond and a sigma bond. Okay, so a sigma bond is shown like that. That's a lowercase sigma in Greek, I will assume. It's a single bond. A single bond is a sigma bond. So they are the first to form. All right, so they are the first bonds to form. Okay? And they are also, the way they're defined as they are parallel to the electron orbital, we'll say. All right, they're parallel to the electron orbital. What that means is, let's say I have carbon and oxygen. This first bond right here, that's called a sigma bond. Okay, so when I have one bond, it's a sigma bond. A pi bond is when that second bond forms. That's called a pi bond. Okay, a pi bond is the second bond to form. So a pi bond is the second or third. Second or third bond to form. So they're the second or third bond. So in this case, I have a double bond here, so I have one sigma and one pi. All right, sorry, my cell phone is going crazy. And then here, these are above or below the sigma. All right, they're above or below the sigma, and they're a little bit weaker. They're a little bit weaker because sigma takes kind of the prime spot. Sigma takes the prime spot where it's nestled right in between them, and it works really well. It's really, really strong. Pi bonds are kind of above or below that, and so they're a little bit weaker. So a double bond really isn't twice the strength of a single bond. It's a sigma and pi strength. So it's 1 and a little bit more, or 1 and a little bit less than 2, I should say. So another example would be, let's say, a nitrogen-nitrogen. All right, the first bond to form will be my sigma. That's going to be my strongest. I'm going to have a pi bond on top and a pi bond on the bottom. All that you really know, whoops, I feel like one got, oh no, don't do that, don't do that. I feel like one got away from me. There we go. There we go. So the sigma forms first, and then the pi on top and the pi on the bottom. So they are similar. They are pretty much exactly the same thing. The only difference is they're stressed a little bit because they're above or below that prime optimal sharing. And as a result, they're just a little bit weaker. So you have a single bond. A double bond is not quite twice the strength, and a triple bond is not quite 3 times the strength. It's a little bit different. Oops. So that is resonance structures, bond length and strength, and pi versus sigma bonds. All right, have a wonderful day, and I will see you all in class. Bye.